Alright guys, so welcome back. So now guys, we're going to move on to a completely different topic, which is chemistry. Chemistry is arguably one of some people find it difficult, some people find it easy. It varies, and to be honest, with practice, I think you can become really good at chemistry in BMAT section 2. Either way guys, well done for coming this far. We've covered at this point the maths part of section 2 of the BMAT and also the biology part. We're now going to move on to the chemistry part, as I say. So without further ado guys, let's move on. So firstly guys, just going over the most common topics that come up in BMAT section 2 chemistry. So the first one in capitals is calculations. So calculations come up every single time, and it's very important that you practice these calculation questions because there's common tips and tricks that if you follow them, it would put you in good stead in the exam. Number 2 is reactions, which we're going to cover shortly. Atomic structure is quite common, but it's quite easy marks. Kinetics again is very common. And yeah, those are the main ones guys. I would say is definitely, obviously in the specification guys, I recommend that you know everything, but these ones in particular, make sure you know in detail. So firstly guys, let's go over the first topic then, which is going to be reactions, and this is including redox reactions. So let's go to the first question guys, and let's read this together. So BMAT 2019 question 2. So this is a cleaning solution is used to remove limescale, which is basically calcium carbonate, from bathroom surfaces. When the solution is sprayed onto the limescale, effervescence, fizzing occurs, and the solid limescale begins to disappear. This chemical reaction is needed because the limescale cannot be removed with water alone. And says, which of the following statements about this reactions are correct? And you have 4 statements. So guys, pause the video, give yourself just under a minute, because remember guys, you have only a minute to answer these questions in BMAT section 2, and make sure to be back after that. We're going to go over the solution. Alright guys, so welcome back. So let's go through this. So basically what we have is the limescale, which is calcium carbonate, and then basically when I add this solution, it's giving fizzing. So if you have calcium, so the common reaction in the specification, this should be popping into mind, is reaction between carbonates and acids. Remember, if a carbonate, I'm just going to write this in word form. So if you have a carbonate, if you react this with an acid, right, what you should get is a salt plus water. And a carbonate, if you like, is kind of like an alkali, like a hydroxide, if you like, right? So remember, acid plus base gives salt plus water, but the difference is with the carbon, you have carbon and a few more oxygens involved, and that basically gives rise then to the fact that you also produce CO2 in these reactions, and that is actually what's causing the fizzing. So that's what's causing the fizzing that we can see here. So the cleaning solution therefore must be acidic then for us to be producing the effervescence. So 1 is true. The effervescent fizzing is caused by the release of hydrogen gas. No, we've just established that it's caused by the CO2, so it can't be this. The pH of the reacting solution would go down as the reaction proceeds. So let's see. So think about it guys. So at the start we have carbonate, which is more or less insoluble, therefore it doesn't really contribute to pH, and we have acids. So at the start we basically just have acidity. So the pH at the start is going to be low, and then obviously over the reaction we're going to produce salt, water and CO2, and more or less salt, water, CO2, they don't really contribute towards pH much. So that's basically going to tend towards, like a pH which is more or less close to 7. So you're going to go low and you're going to go high. So the pH of the solution should actually be going up as the reaction proceeds. So that's going to be incorrect. And then we have the salt produced in the reaction is more soluble than calcium carbonate. That's actually true because obviously salts, so what you're going to produce in this reaction, let's just say for example the acid is like hydrochloric acid, you're going to produce calcium chloride, and all of these salts are going to be soluble in water, whereas calcium carbonate, as it says, it can't be removed by water alone, and the reason for that is because it can't be dissolved in water. So therefore it is more soluble, so that's correct. So therefore 1 and 2, and then this points us therefore to A as being the correct answer. So hopefully guys that has made sense, and as always we look forward to seeing you in the next video. Alright guys, so welcome back. So previously we were doing BMAT 2019 question 2, looking at this question to do with reactions between carbonates and acid, and this is actually mentioned in the specification, so it's really important that you know this. So hopefully guys that was clear. Now we're going to move on to the next question, which is BMAT 2017 question 14. So let's read this together. So disproportionation is the simultaneous oxidation and reduction of the same species in a reaction. In which of the following chemical equation does disproportionation occur? So guys, pause the video, give yourself just under a minute, and be sure to be back after that, and then we can go through the solutions. Alright guys, so disproportionation. So for those of you out there that do A-level chemistry, and if you're doing medicine, I'm assuming that's all of you guys, you probably have come across what disproportionation is in your AS studies. So disproportionation, as it says, is when the same element becomes oxidized and reduced in the same equation. So let's look at 1. So in 1, let's look at what's happening to each of the things. So Fe is going from Fe to Fe and FeCO2. So that's clearly being oxidized because you're going from Fe, which is 0 oxidation state here, and then over here FeCO2, that's going to be +2. So that's just being oxidized there, and copper is going from +2 to 0, and therefore that's being reduced. That's just a simple redox reaction. Now if you look at number 2, let's see what's happening. So copper over in Cu2O is going to be, remember oxygen is -2, therefore each copper is going to be +1. To copper, just copper on its own, that's going to be 0, and copper oxide, that's going to be +2. So this one's actually a good one, isn't it? Because you can see copper is being reduced here, but then it's been oxidized there. So this one is going to be a disproportion. That one isn't. If we look at 3, let's see, Cl is going from 0 here. In HCl, H is, remember, is +1, so Cl must be -1. And then in HClO, remember, O is -2, H is 1, so that's going to be -1. And therefore, this has to be +1 then, isn't it? Cl. And again, this is one you've probably seen in your AS studies, this exact disproportionation with chlorine and water. Because can you see, from 0 to -1 you're being reduced, and then from 0 to 1 you're being oxidized. So this one is it. And then let's look at the next one, 4. Just without me even going through this in particular, guys, another easy way you could just see if it's a disproportionation is basically if you have an element in the reactants, that same element must be appearing twice in the products, because then you can get 2 different oxidation states. Whereas here I don't really see that. Here this is probably just a straightforward, like question 1, redox reaction, because as you can look, barium is only once on the left, once on the right. Chlorine once on the left, once on the right. Sodium once on the left, once on the right. And sulfate once on the left, once on the. So I'm not even going to bother with this one. The last one is worth checking, because look, you have a Hg, I believe, mercury, I think it is. I'm not really sure about. I'm pretty sure it's mercury, but you have Hg here, you have a Hg here, and you have a Hg. So you have a Hg in one of the reactants and 2 different products. That way it's possible to get disproportionation. So in Hg2CO2, each Hg is going to be +1. In this one it's going to be 0, and in over here it's going to be +2. So this is also disproportionation, because look, you're reducing there, whereas you're oxidizing there. So this one is also it. So it's going to be 2, 3, and 5, and therefore the answer should be E. So hopefully, guys, that question has made sense. And as always, we really look forward to seeing you in the next video. Alright, guys, so welcome back. So previously we were looking at this question to do with disproportionation. Hopefully, guys, either way, even if you didn't know what disproportionation was, you know what it is now. And also, it was a quick revision of how to work out oxidation state, which I really hope that has made sense. Now, guys, we're going to move on to the next question, which is BMAT 2017, question 18. So it says, propanoic acid is a monoprotic acid. Magnesium is a group 2 metal. Which of the following chemical equation is correct for the reaction between magnesium carbonate and propanoic acid? So, guys, pause the video, give yourself just under a minute. Be sure to be back after that, where we're going to go over the solutions. Alright, guys, so welcome back. So let's look at this. So monoprotic acid, guys, that just means that it's an acid which just gives 1 proton away. For example, HCl, that only has 1 hydrogen ion in it, isn't it? And a hydrogen ion is a proton, hence why it's called protic. So monoprotic just means it can give away 1 hydrogen ion. And this is the hydrogen ion that propanoic acid is going to give. And it's reacting with a group 2 metal. So this basically is relying upon the fact, guys, that you remember that this form of equation. So if you have a metal, right, and this reacts with an acid, the reaction you're going to get is basically you're going to form a salt, right, and you're also going to produce hydrogen, right? So that's the key bit of information from the syllabus that you need for this question. So let's look at what's going to happen here then. So we this is reacting with magnesium. So oh, sorry, I've actually got this wrong, guys. Sorry, but that piece of information is still useful potentially for a future question. But what we're actually dealing with, sorry, guys, is magnesium carbonate, right? So it's the same as the previous question. Remember, a carbonate reacts with acid, distributes salt, water, and CO2. So let's have a look at this question. So basically, what we're going to produce then is, if we write out what's going on, you have magnesium carbonate, MgCO3. Yep, and this is going to react with this acid, right? But this acid, guys, I can just put all of this part, right? I'm just going to call it, you've probably seen this in biology or chemistry. I'm just going to call this R, like the rest of the molecule. So RH, where H is the acidic carbon. And let's see what's going to happen here. So what's going to happen here is that this is going to form Mg. But remember, guys, when R gets away from the H, right, it's going to be -1. But Mg is going to be +2. So it's going to be MgR2, right? So that's where we get MgR2. And remember, so you get the salt, you also get water, and you also get CO2. So if you have to balance this out quickly, you're going to get 2R there, 2 H's with an oxygen. Yeah, that should be balanced. So we're basically looking at an equation of that form where it reacts with 2 lots of acid. So where it reacts with 2 lots of acid, let's see, CH3CH2, it could be the first one. And then let's see what's going to happen. C3 H5O2 2 water. But remember, this one doesn't have the CO2, so this one doesn't even meet the criteria. So that one we can get rid of straight away. C3H6O2, that's fine. And then this one is not right, guys, because you should have 2. So this one should be 2. So that's why this one can't be right either. If you look at the next one, and also, guys, you need 2 lots of the acid. The next one, this one I think could be correct. Yeah, I think C is going to be correct. It fits exactly what we have over there. So C is going to be the correct answer, and the D and E are going to be incorrect. I'm not going to worry going about this, but if we were to just go for it quickly, here the formula of the acid is completely wrong here. So therefore that can't be correct. And the last one, you have 3 magnesium carbonates. That clearly can't be correct. So the correct answer here, guys, is going to be C. So I really hope, guys, that has made sense. And as always, we look forward to seeing you in the next video. Alright, guys, so welcome back. So previously we were looking at this question. Again, really it's very similar to the previous question. It's just a bit more complicated here because we have an organic acid. But hopefully, guys, it was just really a recall of what you learned already in the previous question. But now, guys, we're going to move on to the next question, which is BMAT 2016 question 6. So it says, which of the following mixtures could not be separated using the technique given? So pause the video, guys, give yourself just under a minute, be sure to be back after that, and then we can go over the solutions. Alright, guys, so welcome back. So let's look at this. So the first option, we have a mixture of calcium carbonate and water, and it's saying, can we separate this via evaporation? That's clearly possible, isn't it, guys? Because all we could do in this scenario is heat up the solution, the water would evaporate, and that separates it from the calcium carbonate. So that's possible. The second one, pentane and octane fractional distillation. You've probably seen this at GCSE, even at A level, if you do AS chemistry. Remember, pentane and octane, they have different chain lengths, and therefore because of that, they're going to have different meltings and boiling points, and therefore fractional distillation is a good choice for that. So that's possible. Silica dioxide, which is basically just sand and water. Yeah, again, you remember here, so if you have silica dioxide and water, you can just filter it, isn't it? So if you get, like, for example, a sieve which has very, very tiny holes, so that silicon dioxide can't get through, but the water can, then you can easily do that. So that's possible. Sodium chloride and water via distillation. Yeah, that's also possible. So remember, you've probably even heard of, like, crystallization, guys, if you've done something like that before. But you can heat off the water and then distill it, and that basically reforms liquid water, and that separates it from the salt. So that's also possible. So that obviously leaves us with the last answer, ethanol and water via separating funnel. This one is not possible, therefore which one could not be separated? Outside this is going to be the correct answer. And the reason for this, guys, is because for me, when I was first doing this question, even I didn't know this, but I got it through a process of elimination. But ethanol and water basically have very similar densities, and a separating funnel basically works on the fact that the two things have different densities. For example, oil and water, which don't mix well, they have different densities, with the water going down. Therefore, those you can separate using a separating funnel, whereas ethanol and water, since they have similar densities, that won't be possible. So that's why E is going to be the correct answer. So hopefully, guys, that has made sense, and as always, we look forward to seeing you in the next video. Alright, guys, so welcome back. So previously we were looking at BMAT 2016 question 6. This question talking about separation techniques. Hopefully that was a quick revision, guys, of the different separation techniques. We went a bit through a bit about fractional distillation, which was good, evaporation, distillation, and separating funnels, how all those work. So hopefully guys that has made sense. And now let's move to the next question, which is BMAT 2014 question 2. So it says, which of the following reactions are redox reactions? So guys, pause the video, give yourself just under a minute, be sure to be back after that, where we're going to go over the solutions. Okay guys, so let's go through this. So remember guys, redox reaction, it says in the name redox, so reduction and oxidation happening in the same reaction. So let's see which reactions demonstrate that. So the first one I think is a good option, because copper in copper sulfate is going to be +2, because remember the sulfate is -2, so the copper must be +2 to make it overall neutral. And the copper in the right hand side is going to be 0, so that's going to be a reduction, whereas the opposite is happening for the zinc. So the zinc is going from 0 on the left to +2 on the right, and therefore that's being that's going to be oxidized. So this is a redox reaction. The next one, let's see what's going on. So the hydrogen is +1 in HCl, because CO is -1, therefore H must be +1 to make it neutral. And on the right in H2 is also +1, so therefore nothing's happening to that. The chloride is -1 on both sides, so nothing's happening to that. And and what else is happening over here? And the sodium is just rating +1, so that can't be a redox reaction. Basically, all that's happening here is just that you're swapping the OH with the Cl. You're basically just exchanging one for the other to give you your products. So that's not going to be a redox. Number 3, let's look at that. So magnesium is going from 0 over here to +2 over here. So that's clearly going to be an oxidation. And oxygen is going from in H2S, remember SO4 is 2-, so each H has to be +1 to make it overall neutral, to 0 over there. So that's therefore going to be a reduction. So that therefore is a redox reaction. And to be honest, if I look at the answer options, guys, remember there's only 2 options, so there's no point of me even going through. This is a good exam technique, guys. There's no point of me even going through option 4 if I'm confident 1 and 3 are correct. So 1 and 3 are correct, but just for completeness, let's go over number 4. So 4, what's happening over here? Let's start with potassium K. K is +1 on each side, so nothing's happening there. I is -1 on each side, nothing's happening there. NO3 is -2 on each side, nothing's happening there. And PB is +2 on each side, nothing's happening there. Again, basically what's happening here, guys, is just the I's and the NO3s are just switching, similar to what we have in option 2. So hopefully guys that has made sense, and as always we look forward to seeing you in the next video. Alright guys, so welcome back. So previously we were looking at this question, BMAT 2014 question 2, talking about redox. Hopefully guys the explanation was clear, and the reason why B was the answer has made a lot of sense. Now guys, we're going to move on to the next question, which is BMAT 2013 question 2. So this is, the following chemicals are mixed together, in which of the mixture will a displacement reaction occur? So guys, pause the video, just give yourself just under a minute, and be sure to be back after that, where we're going to go over the solution. Alright guys, so welcome back. So displacement reaction, remember when we're talking about displacement reaction, guys, we're really bringing in the reactivity series, because remember a displacement reaction occurs when one element which is on its own is more reactive than the element which is in a compound, therefore it displaces it because it's more reactive, right? And for this, guys, you really have to know your reactivity series. I think it might be mentioned explicitly in the specification. It might be worth having a look at that, but either way, I'd say even if it's not, it's very good that you remember it. I know people have their own ways of remembering it, like mnemonics, and whatever your choice is, guys, just flick through a textbook or online and just remember that reactivity series, because it's not only going to help you in this topic, it's also going to help you in other topics such as electrolysis, which we're going to get onto shortly. Okay, so if you look at the first one, we have lead, and basically the two metals which we're competing between basically is going to be lead and aluminium. And what you should know, guys, is that aluminium is more reactive than lead, and therefore aluminium will displace the lead and join up with the nitrate. So these two will displace each other, right? So that one is going to give you a displacement reaction. Number 2, so you have KCl and F-. So this is talking about the reactivity. This is like similar thing, but this isn't really part of the. So when I say reactivity series, guys, there's one for metals, which is the one I'm referring to, and there's also reactivity like kind of series for group 7. It's not really, it's just something you have to know, that essentially as you go up group 7, right, so the elements higher up group 7, they're more reactive than the elements at the bottom, like iodine, etc. But here, so this is a trick question. So F is actually higher up than Cl in group 7, therefore F should be more reactive. However, this is F-, so you only get a displacement if it's F2, not F-. So this one won't actually give you a displacement reaction. The next one, we basically have a contest between aluminium and iron, and therefore what you should know for that, guys, is aluminium is still is going to be more reactive than iron. Therefore, aluminium is going to stay with the sulfate and not displace. So it can't be that one. And the last one, you have a contest between copper and zinc. And remember, copper is really down, guys. Remember, you have copper, silver, gold. That's the one people generally don't tend to forget, the three bottom ones. And copper is far less reactive than zinc, and therefore zinc is going to be able to displace copper and take on the sulfate. That's going to give you a displacement, and therefore, guys, what this gives us then is D as the correct answer. So hopefully, guys, that has made sense, and as always, we look forward to seeing you in the next video.